Hello, this is Professor Urbis-White. Today we will talk about word problems and applications related to lines. You are going to go a little bit deeper when we do this at the intermediate algebra level, but I'm going to try to keep it at the beginning algebra level, and I kind of give you a feel for how the lines work with the word problems. Okay, here's a typical word problem. The words usually indicate some kind of ordered pair that you'll need to put on a graph. And then there'll be something in the problem about something per something. And that when you see the word per, that should kind of get you going on the slope. So let's look at that. Mary was 1 mile away from her house after 15 minutes. So I can write down what the heck is going on. 1 mile away after 15 minutes. She was 4 miles away after 1 hour, which is 60 minutes. Draw a graph of her trip and calculate her rate. Okay, these two match, miles and minutes, miles and minutes. Probably I am doing this, the minutes or hours on the x-axis and the miles on the y-axis. If I'm doing every 15 minutes, watch. 15 minutes, 30 minutes, 45, and 60 minutes. Let's change this hours to minutes so it doesn't confuse us. 1 mile, and then let's do these in miles. 1, 2, 3, 4, and so forth. She's 1 mile at 15 minutes, and she's 4 miles at 60 minutes. And guess what? If she is going at a constant speed, that's what it will look like. Now, it says draw a graph, I did, and calculate her rate. What is rate? Rate is like miles per hour or miles per minute. So that's the slope, rise over run. So let's get the rise and let's get the run. This is like my x1, y1, and this is like my x2, y2. Plug them in. Yeah. This is the other way around. So I had the, let's do it that way because I want to do it y over x. So let's go. This one is my y1, x1, and this one is y2, x2. You know what I did that for? Because I always measure it miles per hour. Hour is in the denominator. So miles is the y coordinate and the hours and minutes is the x coordinate. So let's put this one, y2 minus y1, 4 minus 1, x2 minus x1, 60 minus 15. So that one is going to give me 3. And then this one is going to give me 45. It's 3 over 45, which is 1 over 15. What? I divided miles per minutes. And that is actually my slope. And you go rise over run. And make sure in the word problems, you are going to have a situation where you're going to have some units for the rates. And I did it per miles per minute because I was given minutes and miles. You could have done the same problem taking minute and the miles the other way, minutes as the y-axis and miles in the x-axis, but that doesn't make a whole lot of sense because we measured the rate usually miles per hour, distance over time. Okay, let's have another one. Joe rented a car from a rental company that charges $60 a day. So a day is $60 a day. So that's kind of a rate. Plus 25 cents a mile. Draw a graph and estimate how much he would pay for having driven 45 miles that day. So I go, okay, well, I have the dollars and I have the miles, so I'm going to have the miles on the x-axis and then dollars on the y-axis. That makes sense. So what am I given? He rents a car. He's going to pay $60 no matter what he does, even if he parks it in the, in the garage. So if he drives nothing, he will still pay $60. So let's go 10, 20, 30, 40, 50, 60. So at 0 miles driven, he still has 0, 60 situation. This is my y-intercept, remember? So this one is 10, 20, 30, 40, 50, 60. So that takes care of this $60 a day. Now he's going to start driving. 25 cents a mile, draw a graph. Okay, 25 cents a mile, draw a graph, estimate how much he's going to drive. So I need to have a feel for what the x-axis will go. I know that I'm going to pay 25 cents per mile. So let's get some cents for this. If I multiply that by 10, I'm going to get 25 times 10, that's 250, which is the same as 2.5 for 10 miles. So if I have 10 miles, so if I can put this at 5 miles, 10 miles, 15 miles, 20 miles, 30 miles, and 40 miles, I can get a feel for it. At 10 miles, I am at 2.5, okay? $2.50. Okay, so but I already paid the $60, so I'm going to be at $62.50. So together, this is going to be $62.50, which is around here. Well, let's assume I drove 20 miles. So 25 cents a mile. I'm going to pay $5 extra for 20 miles. So that's going to be around 65. So it's going to be a little bit bigger. So it's going to be pretty flat, but it's going to go some like that. This one is going to be, I drove $10 and I paid $62.50. And this one I drove 20 miles and I paid $65. Do you see how a word problem actually got translated to a graph? I actually have those, my little cheat notes in there in pencil so that I kind of remember what I did. Now, let's do another one. And that's going to be the last one I do. Andrew is the owner of a toy store. His monthly salary consists of $200 plus 10% of the store sales for that month. Write a formula for salary Y in terms of the store sales in X. So here we go. My salary is Y. That's in dollars. And it's going to be in terms of store sales. I'm going to make $200 no matter what. And then I'm going to make 10%, which is 0.1, of the store sales, X. And this one is the store sales. So my equation is 200 plus 0.1x. Okay, so let's go to the next step. Knowing that my situation is 200 plus 0.1x at this point, what would be salary when the shop sales are $10,000 that month? So plug it in. Y equals 200 plus 0.1, and x is 10,000. So that will give me 200 plus 10,000 times 0.1, that's 1,000. Guess what? $1,200. Okay, that's pretty good. How about the next one? What would be his salary when the shop sales are $20,000 that month? Okay. y equals, he makes 200 no matter what you do, 0.1 times, this time, 20,000. 0.1 times 20,000 is 2,000. So 200 plus 2,000, $2,200. So the more he tells, the more money he makes. Very good. Now, when you look at what all that means graphically, draw a graph and explain the meaning of the slope and y-intercept. Remember, he made $200 no matter what. No matter what means, here was your equation, 200 plus 0.1x. So if he sold nothing, he would make $200. Does that remind you anything? That's your 200 is your y-intercept. Okay? 0, 200. So let's put this money he makes. And these ones are in thousands because it looks like the sales are not like $1 or $2. It's in thousands of dollars. So this is in thousands. Let's go. I have 10,000, 20,000, 30,000. It's a trick that you can use with the scales. When you have big numbers, label it in such a way that these numbers mean 10,000, 20,000, and so forth. And this one, you can do it as, since he's making like 1,000, 1,200, and those kind of things, you can do it as, let's say, each one is a tick mark of $200, 600, 800, here's 1,000, here's 1,200, 14, 16, 18, that's 2,000, and so forth. So I can label it that way. And then let's see how that works. Okay, so this is my 0. He's going to make 200 no matter what. And remember, in the previous one, when he sold $10,000 of stuff, he made $1,200. And when he sold $20,000 worth of stuff, he made $2,200. What that means is, this one is 10,000, comma, 1,200. That's my ordered pair, 10,000, 1,200, right here, because this one is 1,000. And this one means when he sold 20,000, he made 2,200. This is my X, this is my Y. When he sold 20,000, he made 2,200. 2,200 is around here. Guess what? I have 3 points. I can draw a line. I actually need 2 points to draw a line, but it all makes sense. And the more he makes, the more he sells, the richer he gets. Here we go. And this is the end of our word problem section. And please practice and get ready for the test.